Ora, muito boa tarde, sejam bem-vindos. Para quem ainda não apareceu aqui, as sessões são de meia hora, sendo que no final há sempre um espaço para perguntas. Espero que tenham gostado, espero que de manhã tenham aproveitado bem a sessão e que continuem a aproveitar esta tarde que vai ser cheia de sessões fantásticas e o dia da manhã também. A primeira sessão desta tarde vai ser apresentada em inglês, portanto vou aproveitar e fazer já a transição para inglês. So, as I was saying, the first session it will be delivered in English, and it's going to be presented by Innowave. So I'm going to pass the word to my colleagues, that they're going to present themselves, and enjoy.
Thank you.
Hello.
Thank you. 1, 2. Can you guys hear me? Perfect. So first of all, thank you all of you for being here. We're going to be talking in the next 30 minutes, very high level, very fast fashion, machine learning ops, or MLOPS. It's about bringing two worlds together. So we're going to be discussing first, or the first part of the presentation is going to be about machine learning and AI, and the second one is going to be about DevOps. Then we arrive to the third one, which is the organic way of doing things, which is MLOps. And then we're going to do a brief demo presentation with a pipeline to show the potential associated with this. Okay, so moving forward, I am Gabriel. Probably that's why we're doing this in English, because if I did it in Portuguese, you're going to understand probably half of the stuff that I say. If I do it in English, you're going to understand just a little bit better. So yeah, there you go. And my colleague, Luís Seabra.
Hello. I would not have a problem talking in Portuguese, but...
Yeah, sorry. This is the smart guy, not me. So. All right, so first thing first, the power of AI and machine learning. So there has been a lot of discussion about this. Before we talk about machine learning itself, let's talk about AI in a very high level and understand the power that comes with this technology or this new way of doing things, right? So in here we have two very nice quotes. First one from Andrew New, which basically stated, and this makes a lot of sense, that just as electricity was pretty much very important 100 years ago, AI is going to play a very similar role in transforming things, in transforming and perceiving how we do things, how we tackle situations, how we solve problems, okay? So this is indeed true, and throughout the presentation, you're going to understand why, right? So the second one is from David Copeland, from Microsoft, of course. He goes even further, saying that it's going to really change the way we perceive ourselves as humans, right? Because when we have machines actually doing all the thinking, what really makes us human? What really separates us from the machine, right? So a little bit like matrix-wise. You get the picture, right? So, good. All right. So, AI in the real world, is it helping us? I mean, come on, really, it is really helping us, mostly because it is better than us in a lot of aspects, right? So, it's mostly about the inefficiency in a lot of the tasks that we do as humans, that AI can really take an essential role. In here is about making the right decisions towards stuff that maybe we couldn't make. A lot of the decision making that we do is a lot of the times wrong. So if we apply this technology to that decision making, it's going to make a lot of difference, all right? So of course it is better than us, and also is aiming higher, okay? And thinking about the future, because this is getting better and better and better. Of course, we get more data, we have more chance to understand how this data can be modular and how we can create predictive models. So that brings us to AI and machine learning, right? And this is let's say, a challenge that we have nowadays with regular people on the street, with customers, with pretty much everyone that wants to talk about technology, specifically AI and machine learning. They say that machine learning is AI and AI is machine learning. Well, it's not really like that. It's not that simple, okay? Let's start with AI. So basically AI, we can put it like this. It's about imitating human behavior, just like that. AI is about imitating what we're capable of. At the end of the day, it's about that, okay? Machine learning is one of the disciplines inside of AI. So when we talk about AI, we're talking about a lot of disciplines. The scope can be described as machine learning, computer vision, cognitive services. So you have a lot of tools and disciplines that make part of what we can call as AI, all right? Now, machine learning is one of those disciplines or tools that can make AI possible, right? Sometimes when we talk about AI to a customer, he starts thinking about Terminator or whatever, and the end of days, blah, blah, blah. But I mean, it's not really like that. Of course, we can use AI for the wrong stuff, like everything in life. But of course, we want to change lives through innovation. So doing AI the right way can really affect our lives in a positive fashion, right? So talking about machine learning, what is machine learning? Machine learning is, above all, about what we can call machine thinking, okay? So when we say machine thinking, what does this mean? Okay? So it means that the machine can actually learn from mistakes. Okay? This is a very powerful notion. The machine can learn, right? And how does that learning process happen? Through data. Okay? So we feed a lot of data to AI algorithms, right? Which can then bring the power to this concept, which is machine learning, right? When we talk about machine learning, a lot of the times we encounter this term, which is called deep learning, okay? So, and also when you talk about deep learning, you get this term of neural networks, okay? So, very in a high level fashion, because of timing issues, I just want to say that when you really feed information, petabytes of data, to a machine learning algorithm, you're actually doing deep learning. And when you're doing deep learning, you're using a neural network, okay? So, this is how it works, okay? And imagine the potential of having machines to learn from mistakes and make decisions and predictive analysis about situations in life. The potential is tremendous, okay? So this is the difference between AI and machine learning, okay? So yes, a picture is worth 1,000 words. This is just an example of how we can use machine learning in nowadays scenarios. A machine learning model that can actually detect in a picture the cars that are in that picture. And then, of course, we have the AI to identify the positions and all of that. So this can be applied to pretty much everything, right? So in order for this to happen, we needed to gather a lot of data, feed it to the algorithms, create the model, train the models to make this happen, okay? So this is machine learning right in front of you, okay? So the rise of machine learning. Yes, I have some interesting numbers regarding machine learning. I can say that since 2000, we have 14 times more startups working with machine learning and AI. So that's a huge number. Nowadays, everyone is doing this. If you're not doing it, please start doing it, okay? Another number is quite impressive. In about 10 years, in 2030, the actual business value of AI and machine learning is going to be evaluated in 13 trillion US dollars. 13 trillion US dollars. So that's a lot of zeros. So there you go. Moving forward to voice assistants. Of course, you probably have a Cortana at home, or an Alexa, or a Google Assistant, for sure. And one awesome stat that we found out is that this year, 2020, 50%, half of the internet searches are going to be through voice. Okay, so everything is going to be processed by AI because those smart assistants are going to be using AI, of course, and they learn. So there you go, machine learning. Okay, deep learning. Adoption. 1/3 of IT leaders in the world are starting to do machine learning. Okay, so everyone, well, not everyone, but at least 1/3 of IT leaders, which is a lot of people, are looking into this. And of course, when we want to start doing machine learning and AI in an enterprise, corporation, in my company, or whatever, I want to start using the cloud because the cloud brings agility to these sort of processes that need to be made. Machine learning and AI, it uses a lot of horsepower. So you don't want to be using a lot of bare steel. You want to go to the cloud and have the agility to actually have the machines out of the box for your processing and for your model training, right? Businesses, of course, a lot of businesses are looking into AI and machine learning. And marketing, yes, of course, for customer segmentation and specifically targeted ads, recommendation engines, stuff like that, or marketing campaigns. There you go. A lot of stuff happening for marketing as well. Regarding milestones, what we see, especially in the market, is that the three main terms looked for in hiring websites or whatever are machine learning, NLP, and deep learning. So if you are an engineer and want to start doing data science, my friend, that's the way to go. So yeah, a lot of positive stuff is going to happen regarding this discipline. Okay. So this is another number which kind of, it blew me away when I saw this. This is just for the last year. So a year ago, the first quarter, this is the amount that was funded to machine learning worldwide. 28.5 billion US dollars, all right? So outstanding, okay? So of course, real use cases, health. We can detect skin cancer. We can detect breast cancer with a success rate of 90%. I mean, this is incredible. I'm not going to be treated by humans. I want to be treated by a machine that can detect if I have cancer or not, okay? So very important. Just today, as I was driving here, I listened to a podcast and I heard an interesting story about the coronavirus outbreak. We had a company that actually warned the authorities about this outbreak happening. By late December, they sent a warning to the authorities and said, hey, our algorithms predicted that this was a possibility. They detected a flaw. So there you go. The power behind this is amazing and can really affect our lives in a positive fashion, right? Transportation, of course, car companies, they are working into this a lot. Specifically, transportation companies which work on revenue and auto margin, they're really waiting for this to happen to actually make money, right? And that's why they still have investment. Agriculture, yes, doing machine learning and predictive models to understand how the crop is going to be regarding the weather, how the quality of the crop is going to be. Finance, of course, stock market to do trade deals, the ups and downs of the market. It can detect this or predict the situations. And e-commerce, yes, of course. Fraud detection is very important nowadays. So AI can work and machine learning can work for fraud detection, for recommendation engines and stuff like that. So, of course, a lot more. If we keep talking about the use cases, we're never going to leave this room today, right? So I just want to talk about one specific use case. And we arrived to the awesome slide of this gentleman, or lady, of course, doing a spacewalk. So it is amazing. It is amazing how we as mankind achieved so much, right? To put a man in space, do a spacewalk, conquer new worlds, whatever you call it. And this guy is looking down to a little bit of planet Earth, and he sees this. So this is from the Australia fires that really devastated the country. If you're going to be using technology, if you're going to be using AI and machine learning, the first thing we should do is about this. Is about making our world better, a safer place, okay? And we do have the possibility and the chance to make algorithms, machine learning algorithms, to solve crises like this. Imagine a machine learning model that can predict fires, and if someone spotted, the beginning of a fire, then we can go and act and mitigate the situation right away. So that way, we can, for instance, solve the situation before escalating into what really happened, okay? So if we want to use technology, if we want to use AI and machine learning, we should use it towards the right things, which is helping our planet and helping mankind, okay? So yes, we arrived to the second world now. We arrived to DevOps, very sexy stuff, right? It's not really a buzz world, sorry guys, but it is true, it is true. this really, really makes a lot of difference. So when we talk about DevOps, and we place this image here just to let you understand, or to make a point. And that point is that DevOps is not about tooling. It's not about tools. I mean, this lady is panicking because, Jesus Christ, Kubernetes, Jenkins, Circle CI, Docker, whatever, everything. Oh, I'm a DevOps engineer. No, DevOps is about culture. It's about collaboration. It's about breaking the silos. And that's why when we want to mature machine learning practices and put a data science team to work in a more agile fashion, we talk about DevOps because it works, okay? So, of course, the best practices like continuous integration, continuous delivery, continuous testing, and continuous monitoring bring behind a lot of tools. Makes a lot of sense, right? But the tooling is not the essential bit. It's just the helper bit, okay? Of course, this brings a lot of agility to the data science teams or any other team, okay? So, natural evolution of things, machine learning ops or MLOPS, okay? So it's the way we should start doing this and looking into this, okay? So pretty much it's just a mix of the both worlds that I just explained, right? It's about being able to apply these practices to the training of the models or the machine learning models, right? It's about creating pipelines that can, in runtime, in an ephemeral fashion, start training the models, testing the model, monitoring the model, and then deploying the model. And after that, all of the horsepower that I used to do that, I just take it away. And that has a terrific impact in our cost saving, okay? So it's about this, it's about automation, okay? It's about testing, it's about making everything more agile, okay? Of course, if we want to do machine learning and we want to train models at a large scale, we're going to go to the cloud. We can do it on premises, but it's going to be painful. So we do it on the cloud, and we scale up. We do the training in a scaled fashion, okay? It makes a lot of sense. So in this slide, we have the traditional model versus the new way of doing things, okay? So before, or nowadays, depends on how you do it, we have the data science team actually manually training the models. This means that they go to a lot of data, okay? They feed from that data, okay? They create the models, they train the models, and of course, we have a lot of bare steel or machines here involved. We have the machine, the models and the neural network that I just discussed a few minutes ago. And after the training, we can deploy it, okay? We had a lot of bare steel here, okay? Or cloud components or whatever, okay? So this is very manual, it's very old-fashioned, it's very painful, it takes a lot of time, okay? If we want to make this something like we want to train models throughout the day or throughout the night or the weekends or whatever, we need to make this automated, okay? So the new way, of course, it's pretty much like a similar pipeline in DevOps, okay? You want to build your Docker container, you're going to do your unit testing, your integration testing, you're going to do your Sonar Cube analysis and all of that. And in here we apply the same concept. Now with the collaboration between more than one specific profile, we can have, for instance, data engineers here feeding more data and triggering a pipeline. And this pipeline, what it would do is start training the models, okay? So when we train the model, we read from data, we then validate the model, we can also monitor the model and release it, okay? So everything automated through a single pipeline, and the most essential bit, the most important part here, collaboration, okay? So it's about the cultural thing, okay? All right, so we're running out of time, so now the demo. Luís is going to take care of that.
All right, thanks, Gabriel. It's not yet, sorry, could you flip back to the presentation? Still have a couple of slides before that. Okay, so first I'm going to introduce a bit the demo, which is taking some of the concepts and even tools that Gabriel was mentioned about and applying them to the world where I come from, the machine learning world. Okay, so about the demo. Here we are. Okay, so the objective of the demo is to show how we train a deep learning model using Azure DevOps and DevOps best practices. We're going to focus on the process, on how we do it, on what's the generic architecture for this MLOPS process. So I'm actually not going to be talking about something that's also very interesting here, which is what is exactly the deep learning model, why are we doing it, but I can tell you that we want to train an application, a computer vision application, that reads images from cars and detects if they have scratches or bumps. Just paints them over. We'll see a demo working, I hope. Yes. But you can also think about what you can use this for. So I think this is nice because we're doing machine learning, I'm doing the model, and then artificial intelligence decides what to do with this information that machine learning extracts. And we're going to use some of the concepts that, that I want to emphasize that Gabriel talked about. We can provision compute resources on the fly, both to train models and then to provision inference engines. We're going to register training experiments as they go on Azure Machine Learning Service, something very important for data scientists because then we can analyze the quality of the experiment that we just run, the training experiment, the epochs, the accuracy, all that stuff that you can hear in other talks. And in the end, we're going to containerize our Python and TensorFlow application and deploy it to the cloud to be consumed by any other API and artificial intelligence application. Okay, so this is our pipeline. As you see, it's influenced by Gabriel's slides. So a key point here is that I'm going to trigger our pipeline. Is hosted on Azure DevOps by Microsoft. I'm going to trigger it on demand. In real life, we want to implement a continuous integration process that every time a developer or data scientist, as Gabriel was saying, this is a collaborative effort. It's going to trigger every time there's a commit to the repo, it's going to commit a full build pipeline. So the developer, data scientist uses the tools that we like, Python, TensorFlow, Keras, to define the deep learning model, gets data from somewhere. It goes to the Azure DevOps pipeline, it provisions compute resources, it starts training the neural net, it monitors the training as it goes, and in the end, it deploys the model. It builds a containerized application, deploys, and then it can be used for something else. Okay? Just a moment. Okay, so now is the point where I'm going to do the actual demo. Okay? Okay, so this is an Azure DevOps project. It's a very powerful tool. I'm not going to go over most of it. Just want to emphasize here that this is overview. We've got your repository with our code. So this is a simple version of our code just for this demo purpose. But the most important point where we can implement this DevOps architecture and framework is in a pipeline. So, okay, so I pick up a pipeline. In this case, I'm going to trigger it manually. And these are the steps of the pipeline. I'm going to be using here first an agent that we've pre-created. This agent in this case is a Ubuntu virtual machine that we have pre-built because there's a lot of libraries that we use for computer vision that are very heavy to build and provision the fly. Because we're going to train a very fast model, I mean, this is probably going to be one of the fastest trainings you've ever seen of a deep learning net. There's no point in waiting half an hour for the computer to build all the resources. So once we pull this machine on the fly from Azure, we define the source. Our code is hosted in this repo, in this Azure DevOps project that any member of the team can contribute, be it data scientist, developer, whatever. And the task of this agent is going to be build and deploy. It's going to use Python as its base layer. It's going to install requirements, libraries that it doesn't have already. It's going to check for that. It's going to fetch data. This is an important point. In a real world example, we would fetch data from SQL Server, Cosmos DB, attached storage. But here, I just have some very small images that are hosted in the repo to make things faster.
Pretty much the same steps that we show on the
yes,
right here.
Exactly. After that, we're going to call the training scripts. Training scripts are going to lead some neural networks configuration. It's going to build the architecture. It's going to feed it to TensorFlow and Keras. It's going to get to the data, and it's going to build a network that is being trained on this data. After the model is done, it's created, we want to make it available for somebody else, because I think this is an important thing of this MLOps movement is that no, for me, machine learning is not only enough nowadays to just build your model. You have to make it available to the world in an efficient fashion. So we build a containerized app that pulls all the necessary libraries from Python and system requirements to make it available as an endpoint. So we build a container using Docker. And after it's built, we publish, we deploy this container to some container registry. Again, we're all using Azure Technologies foundations here, so that it can be consumed as an endpoint by other applications. Okay, and I can just click run, and off it goes.
Of course, this can be run through continuous integration
Exactly,
when someone commits to the repo. So yes, for demo purposes, we're doing it on demand.
Okay, so you see it's starting, it's provisioning resources. Using Python, it's checking if libraries are installed in this pre-built virtual machine or not. It's installing them on the fly. Then it's fetching data. In this case, it's simple copy from the repo. And now it's training the model. One important thing that I emphasize is that we want to know how the experiment goes. I just don't want to have a binary in the end. And the common way to do that is that we can connect more resources from Azure to register this. In this case, I'm going to use Azure Machine Learning Service. That if I refresh, this training round is going to be registered as a run in my machine, in my experiment. See here the date, 410? This is us. That experimental training round has been fully logged here with all the detail that I can possibly imagine and want here. And the data scientist can run many experiments at the same time and compare them and then decide here between what are the models. Because sometimes it's not the first, or most of the time it's not the first model that we get that is going to be what we want. And we can, so this is, data scientists can also use their, they can also do their analysis job here while the pipeline is running. And it's been, as I promised you, it was very fast training, 20 seconds. And even the build container and deploy container, because this is an experimental demo version, was very fast. So the model was trained, the container to wrap it was built, and then it was deployed to a container registry on Azure. Okay, so, but now I've just shown you about the process, the framework, how to do things. But I think we have interesting stuff to show you. So what does our app actually do? So I'm going to select the photo of a car. Here, you see, it's got scratches. And I'm going to send it to one of our deployed models. It might take a while because of network connections. This is going to a deployed model that we have online. And okay, so this is just to emphasize all the steps that we can trigger.
That's a little bit faster.
Wow, yeah, internet is good here. And you can see our neural network, not the one that we've trained 5 minutes ago, obviously, because it's just 20 seconds. But it was able to detect most of the scratches of the car. And this is the power of MLOPS. We can work collaboratively and create a model that is deployed online, and then any other application can use this, pick up on this, to build AI.
Exactly.
I think that we can switch now back to the presentation. Hello? Switch, please.
Can you guys switch to the presentation?
Right. It's not the last.
Okay.
Okay, yeah, this is...
It's pretty much, the demo was about proving this point, but it's also about proving that the images or the detection is not complete. So it's about improving the model.
Yes.
It's about making this process iterative. It's about making it cyclical throughout the day, throughout the weekend, overnight. We can have these models being trained by the collaboration that was done by the entire team. Not only data scientists, but also data engineers and developers, okay? So I hope you really like our presentation. Thank you so much for being here. If you have any questions, please feel free to ask. Thank you.